Hello and welcome. My name is Gordon Smith, and today we will be looking at what's new in ECL Watch, the ECL extension for VS Code, and finally the visualization framework. As this presentation is pre-recorded, you can ask questions in the chat window at any time, and myself, Jeremy, Jamin, David, and Kanal will be on hand to answer the best we can. Today we are going to start with ECL Watch as it's currently undergoing a complete rewrite and as such has the lion's share of what's new features. Let's start with taking a quick look at its history. It is over 20 years old and started life as a set of XML SOAP services combined with XSLT transformations to produce the HTML. This was time before Chrome, Firefox and Safari, when we lusted for MP3 players that looked like this. Heck, this was before some of our interns were even born. Standards were, well, the Wild Wild West. This is what it looked like for those who don't remember. To steal a phrase, it was boxy but good. In 2013, we introduced the new ECL Watch based on ES5 standards. Not only did it have to work with the corporate mandated IE8 of the time, but it also needed to support the browsers which the cool kids were already switching to. It is the ECL Watch we all know and love. If anyone disagrees, I will refer them to Regulation 21 of our official policies. So, it's now 2021 and web technologies have moved on. So it's time to replace the old new ECL Watch with a new ECL Watch. A newer ECL Watch? A modern ECL Watch. Suggestions welcome. This rewrite actually started back with version 7. At the time, we were locked into the now end-of-life Dojo framework and knew we had to move on to a more modern alternative. Step 1 was to move from the Dojo build environment to a modern one, in this case Webpack. This first step was hugely important as it allowed us to start introducing a bunch of new technologies into our build environment. All new code was now being written in TypeScript. We also switched to the Node Package Manager, which simplified the hosting and versioning of third-party libraries. We migrated the HPCC platform communications layer over to use the one from the visualization framework. After all, code reuse makes my boss happy. The bulk of the work was always going to be the porting of the existing web pages to the new framework, so we took some time to reevaluate the current state of front-end development. We settled on React for our user interface rendering. There are many factors that influence this, from not wanting to get locked into another complete ecosystem to the fact that ECL Watch is a 100% client application. We then needed to pick a React user interface library from the current frontrunners. Fluent UI won out as it's modern, under active development, and has that corporate look and feel that most of our ECL developers will be familiar with. It's developed by Microsoft and powers the Office 365 and MS Teams web applications. Some additional glue and we were ready to start the bulk of the work. The final goal will be the retiring of all ES5 code bases. It's demo time. Apart from retiring all the ES5 code under the covers, we had 4 key goals we wanted to achieve. Firstmost was ensuring that the current users would be able to switch easily. To this end, we have mostly kept everything in the same place. Switching to the modern ECL Watch is just a matter of selecting the menu, and we will instantly see that everything is roughly the same. The main icons have been moved to the left-hand side, but after that, the work unit and the work unit details are roughly in the same place as they always were. The same will be true for logical files. Roxy services. and of course topology. Next, we wanted to make the address bar honest. In other words, the web address should be somewhat logical, inviting the user to manually edit it, copy it, bookmark it, and even email it. As the user navigates the modern ECL Watch, you will see the address bar is being updated with a sensible address. The user can change the main view by changing this address. In this case, the user is filtering the work unit list to the Thor jobs. Alternatively, they could filter by HTHOR or even Roxy. These web addresses can now also be bookmarked reliably, both in the browser and internally where the data is stored for that user in DALI. Along with the honest address bar, we also wanted to make sure that the forward and back buttons now work as advertised. While this may seem like a very basic web feature, it is one that has been lacking from the existing new ECL Watch. In this example, you can see the user randomly clicking forward and backward and the page being updated appropriately. You will also notice that there are some breadcrumbs to facilitate navigation. The next major difference the ECL developer will notice is that the entire user interface is a lot flatter and that a lot of the nested tabs are now gone. They will also notice that all the hyperlinks are now real hyperlinks, so the user can copy links and open a new tab as required. Here we can see the user navigating and opening links in a new tab. This will be very useful when the user wants to keep a page they know they're going to return to in the future. Every single hyperlink will work this way. So while we may have lost some of the embedded tabs within ECL Watch, the user can now persist tabbed pages as they see fit. It's worth noting that the hyperlinks extend to menu items. So while the future is bright, it is also worth noting that it doesn't have to be. Not only does the modern ECL Watch support dark mode, it has been architected to make custom theming in the future a very easy exercise. Be warned, there are other changes as well. For example, metrics and graphs has been overhauled to take advantage of cutting-edge browser features like WASM and web workers, improving the graph rendering time significantly. Here you can see, as I randomly scroll through the activities, how quickly the renderer synchronizes. We have the usual zoom to width, zoom to fit, and zoom to selection type features. There is now a free-form filter. Multi-selection will resolve the attributes into a crosstab. And finally, the overall layout can be manipulated by the user however they like. This will then be persisted again in DALI. Next, we're going to recap what has been added to the ECL extension for VS Code over the last 12 months. First up, we simplified the launch configuration settings, added extra support for proxy servers, and added better digital signature support behind the scenes. As you can see, the launch configuration still resides in the same location. The contents of the launch configuration have now been simplified and are the bare minimum settings needed to connect to an individual HPCC platform. Opening an ECL file, we can now see that the launch configuration is front and center here on the status bar, along with the target cluster, an icon showing whether or not the HPCC platform is accessible, and finally a pin icon, which allows you to pin a specific configuration to a given ECL file. Changing the launch configuration is a simple matter of clicking on the item in the status bar, and you will be presented with a list from the launch configuration.json. Similarly, changing the target cluster is just a matter of clicking on it, and you will be prompted with the list of target clusters from that platform. If I open the GenData ECL file here and select localhost but Thor, I can now pin that configuration so that it'll always be associated with this specific ECL file. Switching between that and the crosstab.ecl file, you will see that it will revert to the hthor for the crosstab and back to the Thor for the pinned one, and back again, it's back to the hthor. It'll default to whatever the previously selected combination was. Next, you should notice that there is a new submit button and a compile ECL button handy here, so we don't ever have to go back to the debug and run configuration page. Submitting ECL is just a matter of clicking that button. Finally, we have added additional visual cues for when a HPCC platform is not accessible. If I switch the launch configuration to be the HTTPS, which I am not running on my machine, you will see that we have unable to show any results. We can get the X icon down in the status bar. We have the unable to connect warning here, but more importantly, we are no longer able to submit or compile ECL. Again, going back to the pinned item, you can see that the list of work units has now been activated, and that the submit button and the compile button are now activated again. The big ticket item, which was added nearly a year ago, was the work unit tree and integrated result viewer. The work unit tree is located next to the file view tree. It consists of several parts. The title bar will have the name of the launch configuration that is currently selected. This will match the name that is down in the status bar. Next, you will have the option to switch between My Work Units and All Work Units. There is a button here to refresh the list. And finally, there is a button to launch the ECL Watch page for that environment in an external browser. The tree items itself consists of work units grouped by days and by weeks and ultimately by months. A work unit item can be expanded to reveal the results summary for that work unit. Clicking on any result or clicking on the work unit itself will display those results in the bottom panel down by where the terminal is. I just clicked on result 3 of the GenData work unit, and it is now showing those results in this panel. I can toggle between the different results by selecting these tab items below. For each tree item, you also have the ability to open the ECL Watch page for that work unit in an external browser, or open up the result view specifically in an external browser. The result views are displayed down here next to where the terminal is normally displayed. It will display all the results for the nominated work unit and has a few additional context menu items. Clicking in the results themselves will give you the option to copy a row as ECL or copy all as ECL. Right-clicking on a column header will allow you to copy the column as ECL or again copy all as ECL. On the top right menu item for the results, you get another option to open up ECL Watch specifically for that work unit. The next feature is the HPCC Systems Resource Panel. It gives easy access to ECL bundles and client tools. The resource panel is selected by clicking on the HPCC Systems logo found in the right-hand side bar. It provides the user with a list of all the available ECL bundles and all the currently installed client tool versions. ECL bundles can be installed easily by clicking on the Install button, which looks like the cloud. Once installed, you will see a tick mark and you'll see the version of the bundle in question. There is also a link to open up the home page for that bundle in an external web browser. The Client Tools tree shows you a list of all the client tools that are currently installed on your system. You can nominate which one you want to be the default by activating it by clicking on the little tick mark. Alternatively, you can click on the version of the client tools in the status bar and select it from the list there. The auto detect feature will try and pick the best version based on what version target platform you are sending the ECL query to. Finally, there is a little terminal icon beside each client tools version. Clicking on that will open up the ECL terminal, which will have all the pathing set up so that all the client tools will just work. Finally, there are two more notable features. Localization support, which includes translations for the same set of languages that ECL Watch supports, and ECL code signing. When paired with a HPCC platform instance that supports code signing, this feature ensures that the signed ECL has not been modified since the digital signature was added. Finally, we will turn our attention to the visualization framework. While the visualization framework has been continually evolving throughout the year, there is one new visualization which is worth highlighting: Observable Markdown. This visualization enhances a traditional Markdown document with an instance of the open source Observable HQ runtime engine. For those folks who haven't had the pleasure of visiting the Observable HQ website, it is an excellent visualization and data science resource. For this demonstration, we are going to start off with an empty observable Markdown document called test.omd. The first thing we're going to do is we're going to enter some regular Markdown into it. Clicking on the preview button will display that Markdown rendered in a web page. The next thing we're going to do is add some observable JavaScript. This is done by simply entering it inside a regular code section. In this case, it's MOL equals 40 plus 2. If I save that, you can see it's evaluated that value and inserted it into the web page. What I can now do is I can actually take that result and embed it directly into the Markdown, somewhere sensible. What is the meaning of life? Answer: 42. The next thing I'm going to add is some ECL code. This ECL code is essentially going to read an athletes database from Thor and output it to a named result called athletes. What we might want to do is then render that data inside a table inside the Markdown. Luckily, Observable HQ has an inputs.table built in. Now, at which point, I'm going to have to convert this OMD document to ECL. At the moment, this is a manual process, but in the future, it will be streamlined and should happen automatically. So I'm going to right-click and export to ECL. I'm going to export it to test.ecl and override the existing file. The next thing I'm going to do is double-click that file and have a look at it. It is quite simply the ECL we had embedded into the observable Markdown document. But if we look closer beside the test.ecl, we've also got a test.manifest and a test.html page. These will be embedded in the work unit and will be able to be rendered as a resource in the ECL Watch page. So if I go ahead and submit this ECL, we can see it's submitted, and I'm going to launch ECL Watch and head on over to the Resources tab. We will see the test.html, which got embedded into the work unit, and clicking on it, it will now come along and render the Markdown, including the output from the ECL query. Now, returning back to my OMD document, the next thing I might want to do is visualize it in a more pleasing way. So I head on over to the Observable website, and I have a preloaded page here which is a tutorial on how to use Observable Plot, which is a very flexible rendering, a graph rendering tool. By coincidence, they also happen to be rendering data that looked very like the data I had on my Thor. So I'm going to take that URL and come back to my observable Markdown document, and I'm going to import a notebook. Paste in the URL, enter, and it has now imported the observable notebook from the website. You can see we have a file attachment called athletes there, but in our case, we're not interested in that because we've already declared our own athletes dataset here. So I am going to delete that, and I will delete the data in table demo I gave a moment ago. Save that. I'm now going to right-click, export to ECL, overwrite the test.ecl file. It hasn't particularly changed. I am now going to submit this ECL, come back to my ECL Watch work units. It will be the blocked item at the top. It's running and it's completed. So again, I'll come over to the Resources tab. I will click on the test.html file, and this time we now have the entire notebook as per the tutorial on how to use plot, except for it's feeding in from data from ECL. Obviously, if we change the ECL file on disk, these charts would then change correspondingly. This brings us to the end of the presentation. Normally I would ask for questions at this point, but hopefully they've all been answered already. If you would like any further information, please hunt us down and we can hang out in one of the ad hoc chat rooms. Thank you for watching.